Okay. Okay. So let us start with the session. So let's see. I guess my screen is presented already. So is the question visible? Am I audible? Am I audible? And the screen, is it visible? So this is the first question which we are going to see today. Can you guys see the question? Like the question, is it visible? And am I clear like in the audio part?
Yes, ma'am, it's visible and it is audible.
Thank you, Rashmi. Okay, so this is the first question which we are going to deal. So they are asking what is the equivalent resistance in the infinite ladder network. So quickly copy down the question and start trying out the problem. Okay, so have you guys tried out the question? Okay, so let us see how to solve this problem. Um, so have you copied down the question? Uh, okay, so as you can see, this is an infinite ladder network. So does anyone have any idea how to solve this? You can see that this R and this R gets it's keeping on repeating, right? So when you can start from here, like let me redraw the circuit in a different way. This RE equivalent. Take the resistance to R to be R and R, R. So I'm redrawing the circuit as such. And this keeps on going to extend. Like it will be going up to infinity. The same ladder network will be repeating itself up to infinity. Right. Now we are asked to find this equivalent resistance. So if it is a simple finite circuit, you know how to solve. For example, if this infinite network is not there, and if they have asked what is the equivalent resistance for this network, then it is easy for you guys to solve it by what kind? By making it as series, and then the combination to be as a parallel, then again series, and then again parallel, then again series. So that's how you will do. But since the question involves an infinite network, we need to find something interesting in this. Means like, see, this is a network which you need to observe, right? Take it to be R dash. So when you see this R dash, it is a repeating loop. Like you can find R getting repeated. Like it is a pattern that is getting followed. So how you can write this? You can write it as R dash, draw the network R and R, and again you are finding the same network is repeating. This is the same network. Since it is infinity, this is also considered to be R dash. Any doubt how this is written? This whole circuit, it is simplified as this. Okay. Uh, Not this whole circuit. Repeating it again. You find an R here and R here. The same R is getting repeated again and again. The same combination, the same pattern is getting repeated up to infinity. So you can find that this R dash is the equivalent resistance of this whole network. But this is an infinite network, and also you can find that the pattern is all repeating. So now you can. This is also R dash. Why? Because the same pattern is again and again repeating. So I'm generalizing it and making it a finite circuit. Before I told you, only if you make it as a finite circuit, you can easily apply series and parallel combination according to your knowledge and then find the equivalent resistance. Now that if this infinite network should be made into a finite network for you guys to capture the idea of uh, using series or parallel combination in order to find the final resistance, like equivalent resistance. So that's why I have made it into a finite network. Right. Now it's very easy. How will you write this out? Now this is just parallel and the combination series. So you can write it out as r dash is equal to r plus r parallel r dash. Right. So this is equal to r plus r dash by r plus r dash. When you solve, like when you cross multiply and do some steps, you will be getting r dash into r plus r dash is equal to r into r plus r dash plus r dash. So you'll be getting r square plus 2r dash r dash square plus r dash r. This one gets cancelled. You have r dash square minus 2 minus r dash minus r square equal to 0. So now here, if you're like finding what is the variable, what is the root which you should find the answer for r dash. So have it for simplicity x square minus rx minus r square. Now solve this by using the quadratic. This is a quadratic function where r is a constant which is given. Now we are in a position to find what is x. So x will be equal to, if you are solving, I guess you will be getting 1 plus root 5 by 2 into r. The another root will be 1 minus root 5 by 2 into r. Since r is positive and also r dash is an equivalent resistance which should be positive, 1 minus root 5 by 2 r is not possible because this will turn out to be a negative root and r dash cannot be negative since it is an equivalent resistance. Now that we've found what is r dash. R dash is equal to 1 minus 1 plus root 5 by 2 into r. Right. Now the question is not yet over. There is one more resistance which we have left in order to calculate the total equivalent resistance. How will you now calculate it? It's very simple. Now you can completely ignore this whole circuit and in place of it you can write like this. How you, so this is the R equivalent. This is the one resistance which I left because in order to get the pattern, see, we need to simplify such that this circuit, this finite circuit which we are getting should be simplified. Okay. If you are like using your method, suppose if you are replacing this as R dash, then the complexity of the circuit will increase. So you need to simplify as much as possible and then draw the finite circuit and then go on with calculating the R dash. Right. So now this R is left out and this is the R dash. Now RE is equal to R plus R dash, which is equal to R plus 1 plus root 5 by 2 R, which is equal to almost like, I guess you will be getting 2.168 R. And the answer they are asking is RE by R, which is equal to 2.168. The ratio is 2.168. Okay. If suppose, okay, so this is what is the procedure. In the place of 2R, if you're having only R, then it is quite simple. Then also you'll be getting the same complexity. If you are having this as RE, this is now equal to RE. So now RE, something like this you will be getting, and you need to solve this like what we did now and try to find the final answer. This is what we should do when such kind of infinite networks they're asking. Okay. So I guess this question is clear. Is it clear or should I repeat it once more? Does it make sense? Can I get any reply from you guys like, for this? Is it understandable? Whatever I thought of? Hello, am I audible? Okay, 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 good. Okay, so this is the next question on probability. Two sides of a fair coin are labeled as 0 and 1. The coin is tossed two times independently. Let M and N denote the labels corresponding to the outcomes of those tosses. For a random variable x defined as x is equal to min of m comma n, the expected value e of x is. So you have m and n to be the two labels corresponding to the outcomes of those tosses. They're asking for a random variable x defined as x is equal to min of m comma n. What is the expected value e of x? Try this out. Has anyone got the answer? 0.05. Rashmi has told it is okay. Okay, let's solve this problem then. Okay. So two sides of a coin shows 0 and 1. The M and N denotes the label corresponding to the outcomes of those tosses. For example, one coin can show 0 and another coin also can show 0. One coin can show 0 and another coin can show 1. One coin can show 1 and another coin can show 0. And both the coins can show 1 1. So this is how the the possibilities can be. And M and N are denoting the labels corresponding to the outcomes of those tosses. So we are asked what is min of m comma n. So when you are computing the minimum of m comma n, it is simple 0 0 0 1. Minimum of both the labels m and n correspond to 0 0 0. Now you need to min of m comma n is the event which is happening, and what is the expectation, like what is the probability of x is equal x occurs. So this is the event that is happening, and p of x is equal to small x. So x can be 0 and 1 from the outputs which we have seen. So the probability of that particular random variable taking the value of 0 is given by 3 by 4. Why? Because there are three possibilities of 0 happening out of the four sample spaces that have been created. From the out of the sample spaces that have been created, and only one out of four possibilities that one can happen. So 1 is 1 by 4. Therefore, what is expectation of x is equal to sigma x into p of x is equal to say I is equal to 1 to 2 because only two events. So xi and xi. So if we can see that the event x is 0 into the possibility of occurrence of 0 into the probability is 3 by 4 plus occurrence of 1 into probability of occurrence of 1 is 1 by 4. So when you multiply, you get 1 by 4, which is equal to 0.25. So we get the final answer to be 0.25. Is it clear with everyone? I guess two people have answered this question. What about the rest? You guys are clear, right? If you have any doubts on this question and the previous question, you can ask out now. So similarly, when they are asking what is the maximum of m comma n, similarly you can write out the labels and then proceed on to form the tabulation for the maximum of occurrence of the two labels, which are two possibilities that are occurring because of in the coins. Like for example, like this, many questions can occur. Means like they'll ask expectation related questions on coins, dices. In dices, if they are like they will ask if like, there are six possibilities. Then when two dice are rolled, what is the possibility that minimum of these occurs? Like minimum of the two dices, whatever output it is coming out of the dices, what is the minimum value? What is the expected value of the output that the two dices show? Like that, many problems in coins and heads can be asked. Okay. So this is the method. Whatever question is asked in the expectation part, just write out whatever they have given and then find the probability of occurrence of one particular event that is happening. Probability is nothing but here you have four possibilities of occurrence, means like 0, 0, 0, and 1. Out of all these possibilities, you have three zeros. Occurrence of zeros is more than the occurrence of 1. So you can see that out of the four possibilities, three possibilities are for zeros and one possibility is for 1. Therefore, the probability is 3 by total number of possibilities is 3 by 4. Number of occurrence of 0 divided by total number of possibilities, which is equal to 3 by 4. Similarly, you can calculate it for the occurrence of 1. So let's move on to the next question. This is also a question relating to probability. A fair coin is tossed till a head appears for the first time. The probability that the number of required tosses is odd is. So this is also a very simple question, elementary question on probability, which you guys can try out. Just try out and let me know the answer. Okay. Um, okay, I guess many of you have answered this. So it's easier for me to capture the idea now. So, so a fair coin is tossed until a head appears for the first time. So once when they give a fair coin in the question, it's very easy that probability of head occurring is equal to probability of tail occurrence, which is equal to 1 by 2. When they say if it is an unfair coin, then probability of occurrence of head will be different and probability of occurrence of tail will be different, whereas the sum between the two will be 1. Okay. So now that they told that, okay, until the head appears for the first time, the fair coin is getting tossed, right? So, but they are asking what is the probability that the number of required tosses is odd. What does odd number mean? 1, 3, 5, 7, etc. or odd numbers. So the probability that the number of required tosses is odd. So first time the student is tossing the coin, if he gets a tail, then once again he needs to toss the coin. Now he can either get a head or a tail, but what they're asking is the probability that the number of required tosses is odd. So the number of tosses should be odd. In order for that to occur, like the possibilities of head occurrence can be in the first toss, or the third toss, or the fifth toss, and the seventh toss. This is what the question is. What is the probability of occurrence of such events is what they are asking. For that to occur, we have the following possibilities. What are they? Like the occurrence of head for the first time, or it should occur only in the third time. Until then, the coin will be tossed. So, first two times, it should be the tail occurrence. Similarly, at the fifth time, similarly at the seventh time. So, before that, there should be tail occurring. Otherwise, suppose in case the first is the tail is occurring, so the next toss, if the head is occurs, the possibility is there. But they're asking what is the probability that the number of required toss is odd. So at the odd the toss, we need to get head. Before that, whatever we are getting should be tail. Then only we'll be going on to the next toss, and that toss should be preferably odd and not even. So we need not bother about this type of choices, right? So the probability of occurrence of head is half. Similarly, the probability of occurrence of all these are half. Similarly, it goes on half into half into half into half. It goes on. The probability, okay, so this goes on like an infinite times. So what do you find? So this is kind of an infinite GP. The probability will be either in the first occurrence it can happen, or in the third occurrence it can happen, or in the fifth occurrence it can happen. Plus this can be 5 times and this can be 7 times. Like that it goes on. So this is equal to half into half square, like that. So you know this is kind of a half cube plus half of power 5 plus. So this is an infinite GP. So we know what is the formula for infinite GP. Infinite GP, the sum is a by 1 minus r, where a is the first term and r is equal to second term by first term, which is equal to half cube divided by half square, which is equal to half. Sorry, half square, which is equal to half by 1 minus 1 by 4, which is equal to 2 by 3. The answer is 2 by 3. So is it clear with everyone? It's quite easy to compute. Okay, so let's move on to one more question. This is one of the, I mean, this is also involving probability, but kind of a trickier question. So they say there are N letters and N addressed envelopes. The probability that all letters are not kept in the right envelopes. Okay, let me make it as a 5, 5. So this is the question. So the probability that all letters are not kept in the right envelopes. Try it out. So you have 5 letters and you have 5 envelopes. All are addressed. The probability that the letters are not kept in the are not kept in the right envelopes. There are many possibilities in which this can occur. But what is the you can tell me the value in fraction, not in the decimal. Tell me in the fraction. Yeah, one guy has told the answer. What about the rest? Okay, so let us solve this question. Okay, so they are asking what is the probability that all letters are not kept in the right envelope. What does it mean? Even suppose in case we have A to be placed in A rightly, B to be placed in B rightly, C to be placed in C rightly, and D to be placed in E and E to be placed in D. Even in such cases, it is considered that all letters are not kept in the right envelope. So one possibility is that we cannot directly compute the number of possibilities such that the letters are kept in are not kept rightly in the right addressed envelopes. We can't count each and every possibility such that this occurs. However, it is possible to count that. But when such questions like seven envelopes and seven letters, so the numerical value, if it increases, then there is a complexity in time which you will face. So you can directly see that this is equal to 1 minus probability of letters placed rightly in the envelope. Simple. It is 1 minus the letters placed rightly in the envelope. This is very easier to compute. How will you compute this? There is only one possibility. A can be placed in A, B can be placed in B, C is placed in C, D is placed in D, E is placed in E. There is only one possibility. So what is the probability? 1 minus one possibility divided by how many arrangements that you can make. A can be placed in total number of arrangements is it can be either be placed in A, B, C, D, E, five possibilities. B can be placed in. So in all these, in case if A is placed in A, then we have four envelopes to be placed, which is free. So now we have four possibilities to choose. Similarly, D will be placed in for say D. Now we C has three possibilities to choose from. So C, if it is placed in C, then D has two possibilities to choose from, and E has only one possibilities. After D gets in, for suppose D is placed in envelope E, then E will have only one such possibility. So there are multiple possibilities like that. So 5 into 4 into 3 into 2 into 1 is what is the answer. So how will you write this? 5 into 4 into 3 into 2 into 1. So which is equal to 1 minus 1 by 120, which is equal to 119 by 1. This is how we can formulate a problem, and such problems are given. We can't directly go for finding out every possibility of placing the letters in the wrong envelope. That can't be done. So in order to ease the calculation part, we are going to use this type of method where we'll be subtracting the probability of rightly placing the letters into the envelope from the whole subspace. Means like 1 minus p of probability of letters placed in the right envelope. That's what is the answer for this question. So 1 minus 1 divided by the total possibilities. How many possibilities can be made such that the letters are placed in the right envelope? All correct letters into the right envelopes is by only one possibility. But with respect to how many possibilities, how many total possibilities are there? Probability is defined as the ratio of outcomes divided by the total number of possibilities. So here the outcome is 1. What is the total number of possibilities? The possibilities of letter being placed in the envelope can be of the order 5 into 4 into 3 into 2 into 1. As I have explained here, there are these many possibilities. So you can subtract 1 by 120 in the from the whole part, means like 1 from the where you can get the final answer. Got it? You can say only one person has answered this, so I guess you guys would have found difficult in answering this question. Is it clear? Is there any
Yes, ma'am.
doubts with? Yeah, yeah. Okay. So if a probability kind of questions like this is given, then read out the question, then find out which way is possible. Sometimes going in the direct way can be possible. Means like if they are asking out what is the possibility of occurrence of uh, three when two dice are rolled. Like some can be three when two dice are rolled. So in that kind of cases, you can write out the samples basis and uh, write out the possibility of occurrence of three out of the total number of possibilities. That type of direct way is possible. Here, it is evident that we can't make it into the direct way because there can be n number of possibilities such that the letter cannot be placed in the right envelope. So we are going by indirect way. Means like we are subtracting out the right possibility of um, mapping the letters to the envelope and uh, subtracting it from the whole probability. So that's what the answer which we'll be getting, which is 1 minus 1 by 1. So another one easy, very simple question which with which I want to end the class. So they have given x of n to be 1 by 3 power mod n minus 1 by 2 power n u of n. They're asking what is the ROC of its z transform in the z plane is. They have given three options, and I want a quick answer from you guys for this. It's a very easier question where you need to know only the ROCs for the given signals. So it's very easier for you. Let me see who answers this. I need to work this out, Hari Prasad. Okay. Yeah. Okay. You can write it in the discussion forum if you want to know the answer. I need to try this out. What's the probability that only one of them means like if one Ram is getting selected, then Ramesh should not get selected. Yeah. What is the answer for this? Is there any final answer that you have? 1 by 4. Okay. Only one of them is getting selected. There can be four possibilities. Ram gets selected, Ramesh should not get selected. Okay. Okay. What is the answer for this question which I asked? It's quite simple only, Hari Prasad. See, you have asked Ram, Ramesh. There are two people. Let me write it as like this. So, have you guys followed out this question? So he's saying that Ram and Ramesh appeared in an interview for two vacancies in the department. So, yes. Okay, let others also, since you're asking it, let others also get an insight about your question. So he says Ram and Ramesh are having, there are two vacancies. Let us say it is vacancy one and vacancy two. What he says is the probability of Ram's selection is 1 by 6 and 1 by 6. Okay, let us take it like this. Like for Ram, the probability that he can be accepted for vacancy one is 1 by 6. Similarly, the probability that uh, Ram can be accepted for vacancy 2 is again 1 by 6. Similarly, Ramesh, the probability that he can occupy the vacancy 1, he can go for vacancy 1, he can be selected for vacancy 1 is 1 by 8, and he can be selected for vacancy 2 as is also 1 by 8. What Mr. Hari's question is, he's asking what is the probability that only one of them will be selected. It's very simple. Um, See, there are two vacancies, B1 and B2. So only one of them should be accepted. Means like either Ram or Ramesh. If Ram is getting selected, Ramesh should not get selected. So what is the probability? If Ram is getting selected, then Ramesh should not get selected. What is the probability? 7 by 8. Means like 1 minus 1 by 8. Plus, when Ram is not getting selected, then Ramesh should have been got selected, which is equal to into 1 by 8, which is summing up to 1 by 4. Yes. He should not sit for the position. Similarly, he should sit for the position. Mm, okay. So moving on to the next, the question above which I have asked. So this is quite simple, right? Yes. Okay. So this question is very simple. Why? What happened to others? People, I see no one answering this question. Come on, answer. Hello. Other than Hari, is there anyone? Rashmi, Prabhat, Bunty. Anyone who knows the answer for the question which I've shown?
Maybe C, ma'am.
Yes. So, okay. Bunty, you can raise the question in the discussion forum. I was not able to find out the question. So you can raise it out in the discussion forum. Soon the team will be getting in touch with that, I guess. So, yeah. Okay. So, I guess, what's her name? Okay. Rashmi has told the answer to be C. Yes. So, we know that for A power mod n, the ROC is A less than Z less than 1 by A, when A is less than 1. Similarly, for A power n U of n, it is a causal sequence. So, the ROC is Z is less than A, say greater than A. So, when you find it, for this ROC is Z greater than 1 by 2, just substituting whatever is in here. 1 by 3 less than Z less than 3 from this. Here A is 1 by 3. Now draw the circle. For first expression, it is from 1 by 3 less than 3. Means like this circle.